Hey guys, it's Graham. I'm about to make a 3D lithophane, and I thought while I was doing this I would shoot various video segments on the process and put it all together and make a little video. Now, there are lots of other videos on YouTube about making lithophanes, and the process is relatively straightforward, but I thought I'd just make one to add to my YouTube channel just to show you how I make them. You may find some parts a little unique and different from what way other people do it, but hopefully you'll find it interesting. For a start, I use a program called Vectric Aspire to create my 3D model for the lithophane. I use 4.5mm white acrylic, and I've got the image of my car here that I'm creating the lithophane of. Prior to this, I have edited that photograph to take out the background, put shading on it, done whatever I needed to do to end up with the result that I want. Import that into the modeling part of Vectric Aspire, and that's what the image looks like when it's imported. For a lithophane, you need to engrave it in reverse, so you need to set it as a negative. So one click of a button to do that, move across, set up my tool paths for my roughing pass. For my roughing pass, I'm using, what have I got, a 1.5mm ball nose cutter that is stepping at around, what am I stepping at for that? Let me just have a quick look here. For that, I'm stepping at 50% for my roughing pass with a 1.5 ball nose cutter. And then for my finishing pass, I'm using a 1mm ball nose cutter, and I've got that stepping at 10% per pass. The rough calculations on time for this are, my roughing pass is going to be around 3 hours and 24 minutes, and my finishing pass is going to be around about 4 hours and 19 minutes. So the whole process is going to take a while, but I'm going to show you how this proceeds when I've got it on the machine, and then take you through the whole process. So I'll save my G-code paths and put them onto USB, take them over to the CNC router, and start the whole thing. We start off by putting a piece of white acrylic. This one is 4.34mm thick. That's what I measured it at, but it's actually sold as 4.5mm thick. Acrylic is never the actual thickness that it's sold at when you actually measure it. There is a reasonable tolerance. So anyway, I'm going to start off, and I'm centering the cutter. The first cutter I'm going to use to do the rough cut is a 1.5mm ball nose. So now I'm going to zero the 1.5mm ball nose, and I'm doing it right on the bottom edge of the acrylic, primarily because this part is not going to be affected by the rough cut, and I need a common reference so that I can then zero the 1mm ball nose cutter that's going to do the final cut. So now I just activate auto zero, the tool will come down, hit the touch plate, and back off a little bit, and that's zeroed. Now I can remove that plate. That plate happens to be 3.22mm thick. So what I do now is I move the cutter just out of the way, and I lower it, and it's all automatic with my Mac 3 software. I will now lower that by 3.22mm. And now that cutter is set. At that point, right on the surface. So I'll now move that back to the safe zone and back to my center point, which is the reference point for all the machining. Now I've got the dust extraction hood in place. I've got my G-code loaded, and I'm ready to start the whole process going. So let's just hit the cycle start, and away it goes. So fingers crossed, I've got everything set right. I've got my spindle set, vacuums on, and we're on our way. So I'll come back in a few hours and let you have another look to see what the progress is like. We were 1 hour, almost 55 minutes in. We're 3 hours, 20 minutes in. And we'll see if this is the final pass, which I'm pretty sure it has to be. So it's finished. Now it took, what am I looking here, 3 hours 30. Vetric Aspire told me it was going to be about 3 hours 40. So that's pretty spot on. I will now just move this away. Let's go this. Let's move the Z-axis up and back, and have a look what we've got for our first roughing pass. And as you can see, it's definitely a car. Don't know whether you can actually, it's a bit hard to sort of show what the depth is like, but I know from what I can see here, I've got good depth, probably around about 2.8 millimeters total depth for the roughing pass. So what I'm going to do now is set up the final pass, which I'm told by Aspire is going to be probably taking 3 hours, 30 minutes. So it might be finished. What's the time now? My time now is about 8 o'clock. So probably about my bedtime, which will be about 11:30, something like that. So should finish. So the final pass is going to be using a 1mm ball nose cutter, but it's going to be stepping at only 10% per pass, and I'm running it at around 20 degrees. So that's going to slow things down a little bit, but let's hope we get some good detail with that. So I'll be setting that up right now. Back to you shortly. We did for the roughing pass, I've now replaced the end mill with a 1mm ball nose. I've positioned my touch plate at the same point as I did when I set up the 1.5mm, and I'm just going to activate Auto Tool 0, and that will send the tool down, hit the touch plate, back off just so that I can remove it. Get that out of the way. And now I'm going to just quickly move that out of the way, and I'm going to bring that down by the thickness of the touch plate, which is 3.22 millimeters. There we go. And I'm now going to reset 0 and Z at safe. Pass started. It's a 1mm ball nose end mill running at around 30 degrees angle and it's stepping by 10% per pass to give me a nice finish. It's going to take probably around about 3 hours or so to complete, but there'll only be one pass to do it. Oh, I should say, because this is finishing pass is only removing about 0.25 millimeters off the surface. There's not going to be a lot of dust or material to remove, so I'm not actually going to bother running the vacuum system just to make sure that everything's a little bit more quiet. Okay, we're probably through 50% of the final finishing pass, and we're at 2 hours 10 minutes, so this is going to be another couple of hours. The important thing about Lithophanes is that if you want a really good definition, you just simply have to be patient and take it slowly. Yes, I could have done this a bit faster, probably in half the time, but I wouldn't end up with the sort of result that I'm hoping I will get. So I'm quite happy to spend 8 hours or so waiting for this to be all completed, to be really, really satisfied with the result that I get at the end. Right, I think we're almost finished. We've got 4 hours and 43 minutes that it's taken for the final pass, and I'm figuring this is going to be all done within about another 5 minutes. You can take a closer look at the detail. It's just doing the very top left-hand corner of it. So my conclusion is, and my only comment at the moment is that yes, this whole thing has taken probably about a good 8 hours or so to do, and I could have done it faster by taking a coarser approach, by using larger ball end mills and bigger step overs and whatever. But I don't think I would have got the really detailed result that I'm hoping that I will get in the end. So I think from a personal point of view, this is a really nice approach. Probably if I was doing this commercially and trying to sell these things at a reasonable price, then I'd probably have to take a different approach to it and be a little bit more crude. But for me, I don't care how long it takes. I just want something that really looks good at the end. So let's see what it looks like in about another 5 or 10 minutes, and then tomorrow, when I mount this in the frame, we will see what the whole thing really looks like when it's all backlit and done. Finished. I've just retracted the tool and taken off the hood, and you can get an idea of what it looks like. Now, you've got to realize this is in a negative format, so where you see there are raised sections, when it's backlit, will actually end up being almost black. So I'm going to replace the tool now and cut the outside profile, and then I'm going to call it a wrap. Final profile pass, final cut, 4.5 millimeters deep. And we're all done. Here we go. I'm removing this from the spoil board. As you can see, I've used 4 pieces of double-sided tape to hold the whole thing down. I'm going to peel off the backing paper, and we'll soon hold this up to the light and have a look and see what it's going to look like. Right, I've just removed the backing paper from it, and we're going to have a look at what it actually looks like. You can see from this perspective it looks pretty ordinary, and when I bring it up to the light and the light's coming through it from behind, you can see it turns from a negative into a positive, and the areas that were of highest point become black, and that looks pretty good. So I'm really really happy with that. Once that's mounted in its frame and it's all lit up properly, that's gonna look fabulous. So I'm gonna have a good night's sleep. That whole process has taken around 8 hours to do all of that, and we'll mount it tomorrow, and I will let you see the finished results. Good night. So what I've got now is the frame. This is the front section of the frame. This is the back. They screw together like so. And what I've done is I've got brass inserts, M3 brass inserts all around the frame to hold the two halves together. So we'll clean that out. Now the first thing that goes in is the lithophane. Here we go, and that drops in here, and it's positioned in such a way I've got it slightly undersized on two edges, and I insert, this is just a little bit of braiding to give it a bit of flexibility down there. Now somewhere else I had another little bit of braiding. Here we go, and I'm putting that in the bottom here. It's a bit hard to film this while I'm actually doing it, but that just takes up any space requirements. Now the next critical part is what I use is these. Now this is the backlight for an LCD display, and I purchased these from a company on eBay. They're rejected LCD displays where the backlight is perfectly okay. It's powered from 12 volts. You just put 12 volts straight across it, and I've removed the broken or non-functional LCD front part of it, so I'm just left with the frame. Now you can buy these on eBay. You can buy them new, they're not that expensive, or if you've got an old photo frame around or whatever, a small display, never throw it out. You can always pull out the back, because these are just perfect. You couldn't make anything yourself as good as a consistent light over the surface, and you'll see that when I get it actually wired in and going. So I drop that into place and position it, and the next thing I'm going to do is I'm going to solder my 12 volt connector across it, and I'll be back to you when I'm going to fire this up, and you'll be able to see what it's all going to look like. So I've soldered the two wires across, and before I put the heat shrink tubing over, I've just got it powered up. I'm only looking at it from the back at the moment, but just wanted to check it's all okay before I close this thing up and get the wire sorted out. The wire nicely tucked away. You can see why I allow a little gap at the bottom here, and I've got little cutouts to allow for all of this. I will point out that some of the displays come with just a couple of pair of normal wires coming out, and some have this little ribbon cable connector. So it can be a little challenging at times to sort it out. This is the first time I've actually made one of these with it's got this little ribbon connector, so it's a little bit more sort of delicate to work with, and that's in position now, all going well. And I've got my back, which I'll get the right way up, and you can see I've got a cutout. The back's all got it's got recesses and it's vented so that we've got some airflow because these can get a little warm, and I've got venting at the top and 2 slots, as well as having it recessed as well. So now I'll put this on. Should all work out nicely. There we go. So I've got it organized so the cable comes out the side, but it also can fold around like this. So it can be side or it can come out the back. So I'll go and get some screws, and I'll just put a couple of screws in temporarily just to hold this together while I give it a bit of a test, and I'll be able to see what it looks like from the front. Now I'm just putting 4 cap screws in at the moment. They're hex screws, and I've machined the back so that they are recessed in, and I'll just put the 4 in at the moment. But ideally it needs all of them to really button it up nicely. This is a frame that I made some years ago, and it's just been sitting around waiting to be used. So I will now turn this over, and I'll power it up for the first time. Now, there you go. Where's my 12-volt supply? Here's my 12-volt supply. So you're going to see this exactly at the same time. If I've got to try and do this with one hand. Now I'll have to adjust the camera to suit because it's so bright that you can't really see what's going on. There, the camera's adjusting itself. I will lower the brightness of the camera so you can now actually see what it looks like. It's a little bit of a flicker. Where can I get a bit more adjustment? There we go. Now, okay, that's what it looks like. So you can see the difference if I disconnect the power. That's it. And if I reconnect the power, it looks fabulous. So I'll now do the connectors up properly, and we'll have another bit of a look at it. So I've got all the screws in, black hex screws. I've also attached the little stand for it that helps it stand up nice and securely and stably. That's just got a couple of screws here and slots that I can adjust it with, and to make that all it is just a bit of clear acrylic machined out, and I cut a groove also along it, and then I use my heat pencil to just heat up that area along there, and then I'm able to just to easily bend it to the shape that and the angle that I want. So now the cable is coming out the back like that. Stand the whole thing up, and that's what it looks like. So I'll power that up and we'll do some final shots. So I've finished it all up. I've screwed on a piece of clear acrylic across the front. It just gives it that nice professional look, and some people may or may not like it, but I've got it there. I happen to have some black M3 spacers, they're 10 millimeters long, that I used, and then I recessed the black cap screws into the acrylic so the front is completely flush. This piece of acrylic, I found that I actually had it. I must have made it earlier on when I made this this frame, but I did notice that it's a little bit oversized. But I didn't worry too much about that. At least it serves the purpose at the moment. So this will now sit on that, just like that. Or if I want to tilt it back, it can tilt back and be supported by the little stand at the back. The other thing that I use with these is a little RF remote control. There's the remote. They're readily available on eBay. I think they're only like about $6 or $7, so they're not very expensive. They have various functions, but the main one is you are able to adjust the brightness 100, 50 and 25%. I find 25% is, with this particular display, is more than adequate. 100% is just way too bright and a bit too dazzling. So run it at around about 25% brightness is pretty good. So thank you for watching, and I hope you found this video informative and interesting, and maybe provide you with some information about what lithophanes are all about, how you can apply them, how you can do them, how you can make them, and encourage you to give it a go.